Alright, the third model we're going to go over is going to be your Gaussian model. And whenever you have a Gaussian model, it's commonly used in probability and statistics, and it represents populations that are normally distributed. I would use this in class, but most of you guys are not normal, so can't use it. For standard distributions, though, you take this model, y equals 1 over the square root of 2 pi times e to the negative x squared all divided by 2. This is called a bell-shaped curve. And this is kind of what I showed you at the beginning. Don't worry with all these formulas, I will give you whatever you need. You're not going to have to memorize these. On word problems, you're going to be given these formulas, so don't fret, my pet. You'll be all right. All right, example 4. Here we have math scores. So last year, the math scores for students in a particular math class roughly followed this normal distribution. Y equals 0.0399 base e to the power of negative x minus 74 squared, all divided by 114. And this is your x is between 30 and 100, so that is your math score. So the math scores range from 30 to 100, so that's good. Nobody got a 0. And what we want to do is we want to sketch the graph of this function and estimate the average. So what you can do when you plug this equation into your calculator, excuse me, you're going to have this equation when you plug it into your y equals maybe, and maybe. There we go. You type in your function, and you can type it in just exactly as it's written on the paper. And if we want to find an average math score, see, type it in, you get a square divided by your 114. When you plug this in, you should be able to graph it. So if we hit graph and it doesn't show up here, well, I guess we need to change our windows. So if we change our window, x is our math score, so that means we need to change this. It says from 30 to 100. So let's change the x min to 30, x max to 100. And our y min, we're going to find an average, so we're looking for an average here. I'm going to make these a little bit bigger. Let's just see what this does first. So let's go to our graph. And we got nothing. So maybe we change our y values, our y window, to our y min to a 0, and maybe we make our y max a 100. And so maybe we graph this. Do we get anything? Come on, come on, come on. Daddy's new pair of shoes. Nothing again. So let's try zoom and then this other magical feature. It's called zoom fit. So if we type zoom fit, hit 0, and I'm hoping, here comes something nice and pretty. Yes, so why didn't I just hit zoom fit at the beginning? That would have been nice. But notice you get a bell-shaped curve. It goes up, goes back down. You're going to have a max value here. This max value is your average math score. So we need to find our max value. So you hit your second button, then your trace key, and we're going to find our maximum. So we hit 4 for max, and we need a left bound. So anything to the left of that value I can choose. So I'll just choose there as a left bound, and then I need to go to the other side of it somewhere. That looks like a great right bound. So we're going to find a max value in between there. So here's our max. Now which value are we looking at? The 74? Or are we looking at the 0.03? Well, x is our math score. So our average math score then should end up being, this is that score, then our average math score is going to end up being the 74. So we would say the average math score was a 74. And that is how you can use a bell-shaped curve to find an average. And keep in mind, to the left and to the right of that average, you're going to have the same amount of A's and B's as you're going to have F's and D's, which is fair or not fair. In our last math test, we had a bunch of A's and maybe not so many one-legged A's, but we had a lot more A's. So if I would have graded on a bell curve, we would have had a lot more one-legged A's and a lot less two-legged A's. So maybe I need to start doing that. That's a point to ponder. Point to ponder.